Welcome to Algebra 1, Chapter 4, Section 6. We will be increasing our vocabulary with the word reasonable. Something is reasonable if it makes sense or is sensible. We're going to use vocabulary reasonable, reasonableness, and unreasonable. Take a moment, figure out which word fits best, and then restart the video. And how did you do? First one is the reason we use this word. The student estimated to check the reasonableness of our answer. And we always want you to look back at the problem and make sure your answer makes sense or is reasonable. We are looking at some interchangeable words. And we've already talked quite a bit about domain, and we realize that domain is our x value. We've talked a little bit about range, and we know that range is our y value. We have also talked about x value being our input. So you can use domain is our x value or the value being put in, and realize that range is our y value or what comes out after we apply our function rule. In this chapter, this definition is the most important. A relation is a pairing of numbers in one set. So a pairing of numbers can be called a relationship. A relation is a pairing of numbers in one set, called the domain. Domains are x value, or the number being inputted into the equation, with numbers in another set called a range. Our range is our y value, or our output after a number was put into the equation. A relation is often represented as a set of ordered pairs, x, y, with domain being the x and the range being the y. This is essential. A function is a special type of relation or relationship in which each value in the domain is paired with exactly one value in the range. There are three main ways to determine if a relation is a function. You can look for repeated x values, use a mapping diagram, and or a vertical line test. Repeated x values. For example, looking at this relation, we see that the number 3 is repeated. So this is not a function. In the second one, there are no repeated x values. So this is a function. Using the mapping diagram, you can list the domain and range in order and draw arrows from the domain to the range. If the x is assigned more than one y value, it is not a function. Here are two mapping diagrams. The first one, each x value goes to only one y value. So this is a function. In the second one, you see that the 0 goes to two different y values. So it is not a function. In this case, we need to determine whether the relation below this is a function. So what I did is I created a mapping diagram. So in this oval, I put all my x values, and in this oval, I put my y values. Now there are 4 y values, but I only listed 3 because one of them, the -2, is a repeat. Now I'm going to draw my lines. Y goes to -2, 12 goes to -1, 13 goes to -2, 20 goes to 7. As you can see, each x only goes to one y value, so this is a function. Again, I will create my mapping diagrams. So I have 3, 4, 7, and then another 3 that I don't have to put in twice, and 6, 9, -2, and 10 in my other mapping diagram. Now I have 3 goes to 6, I have 4 goes to 9, I have 7 goes to -2, and then I have 3 goes to 10. As you can see, my number 3 goes to two different y values. So that means this is not a function. In problem 1, we want to identify the domain and the range of this relation. So if we look at 4, 2, 5, and 7, you'll see that 4.2, 5, 7, and 4.2 are all x values. That means they are the domain. If you look at 0, 1.5, 2.2, and 4.8, you'll see that they are all the y values. So they are the range. Let's draw some arrows here. 4.2 goes to 1.5. 5 goes to 2.2. 7 goes to 4.8. And 4.2 goes to 0. Does each relation map each domain value to exactly one range value? No. Since it does not, because the 4 goes to two different ones, it is not a function. We can use the vertical line test to determine if a relation is a function. If the vertical line can be drawn to pass through more than one point of a graph, then the relationship or relation is not a function. So the example shown here is not a function. Here are two examples. If I drop a vertical line anywhere on this graph, will it pass more than one point? No, it will not. So this is a function. And on the second one, again, if I drop a vertical line, does it pass in more than one spot? It does not. So this also is a function. Here are two more examples. The first one, if I drop a vertical line anywhere on the right here, you see it crosses in more than one point. So this is not a function. And very similarly here, if I drop this line, you can see it crosses in many points. So this also is not a function. How about these two examples? This, although it's wavy, it does pass a vertical line test. So it is a function. The next one is a vertical line. So of course it is not going to pass a vertical line test. So it is not a function. Looking at problem 2 here, we want to know if the relation 4, 2, 1, 2, 0, 1, negative 2, 2, and 3, 3 is a function. So the first thing I did is I went ahead and I graphed these points. And then let's draw our line. We really don't know what else happened, so we'll just put arrows on the end. Drop your vertical line. So does this pass the vertical line test? Since you cannot draw a vertical line that intersects more than one point, the relationship is a function. So it does pass the vertical line test because my vertical line only touches the graph at one location. Problem number 3, we will be evaluating a function. We are considering the function w of x equals 250x, which represents the number of words, w of x, you can read in x minutes. How many words can you read in 6 minutes? So 6 is our x minutes. So we're going to substitute 6 for x. Now, as the function is evaluated below, we're going to write the justification for each step. So first, we have the original function. So we're going to write the original function. Then we're substituting in 6 in place of the x. And then we're multiplying. And as you see, we can read 1,500 words in 6 minutes. In this example, we're going to use our domain to determine a range for the function rule of g of x equals 4x minus 12. So realize that the domain is a set of input values and the range is a set of output values. And we're going to use this function with this domain to find each output. So first I'm going to put the 1 in. So g of 1 is 4 times 1 minus 12. Well, 4 minus 12 is negative 8. G of 3 is 4 times 3 minus 12. That's 12 minus 12, which is 0. If I put 5 in, that's 4 times 5 minus 12. That's 20 minus 12, which is positive 8. And to put 7 in, I have 4 times 7 minus 12. That's 4 times 7 is 28. Minus 12 is 16. So my range is -8, 0, 8, and 16. Now here comes that reasonable word back into play that we started with at the beginning of this video. If you have 6 quarts of paint to paint the trim of your house, a quart of paint covers 100 feet squared. The function A of Q, Q for quart, equals 100 Q, represents the area A of Q in square feet that Q quarts of paint cover. What domain and range are reasonable for this function? Well, take a moment to think about this. The least amount of paint that can be used is 0 quart. So 0 is your lowest domain value, and that makes 0 your lowest range value. The greatest amount of paint you can use is 7 quarts. So that's going to be our greatest domain value. So we know that our quarts are going to go between 0 and 7. That means our range is going to be between 0 and 700. Do not forget to work through the lesson check. And of course, if you have any questions, make sure you bring them with you to class tomorrow. And also, make sure you feel comfortable with the words relation or relationship, domain, your x value or your input value, range, the y value or the output, vertical line test, and function notation. Finally, mark how well you believe you understand functions. And I'll see you in class tomorrow.